Hello students, in today's class we will see application of Z transforms to solve difference equation. So here, before taking a particular question, we'll see working procedure for problems. So working procedure for problems are first one, we take Z transform on both sides of the given difference equation. Step number 1. Step number 2, we use the unknown expressions for the Z transform for the terms like un plus 2 comma un plus 1. Then next, step number 3, then we obtain u dash of z is equal to Z transform of un as a function of z. Next, step number 4, the required solution un is equal to z inverse of u dash of z. So here I want to take one of the note. So we have seen in the step number 2, that is nothing but u of n plus 2 and u of n plus 1. So Z transform of u of n plus 2 and u of n plus 1, I want to show what is that. So we'll take in the form Z transform of un plus 1 will be Z transform of, that is Z into u dash of z minus u naught. Okay, Z transform of u of n plus 1 is nothing but z of u dash of z minus u naught, and Z transform of un plus 2 will be z square u dash of z minus u naught minus u1 into z raised to 1, z raised to minus 1. So these two are very important. I can say those two are very important to simplify the problems. So Z transform of u of n plus 1 is z of u dash of z minus u naught, and Z transform of un plus 2, u of n plus 2 is nothing but z square into u dash of z minus u naught minus u1 of z raised to minus 1. So using these two and the steps of what here solving the example problem, we will see the actual example. The problem is solved by using Z transform u of n plus 2 minus 5 times u of n plus 1 plus 6 times un equal to 0. Solution. So the given difference equation, that is u of n plus 2 minus 5 times u of n plus 1 plus 6 un equal to 0, will take as it is. Then take Z transform on both sides. Take Z transform on both sides. So we get Z transform of u of n plus 2 minus 5 times Z transform of u n plus 1 plus 6 is a constant, Z transform of un equal to Z transform of 0. But we know that Z transform of u of n plus 2 as per the list. So I will go back here, note. So Z transform of u n plus 1 is nothing but Z into u dash of Z minus u naught, and Z transform of u of n plus 2 is nothing but Z square into u dash of Z minus u naught minus u1 of Z raised to minus 1, and also Z of Z inverse of u dash of Z is nothing but un. These all things we need to remember while applying the example here. Now we'll see. Z transform of u of n plus 2 is nothing but Z square into u dash of Z minus u naught minus u1 of Z raised to minus 1 minus 5 times Z transform of u of n plus 1 is nothing but, I will put a bracket, it is u dash of Z so here I will rewrite once again. So Z transform of u of n plus 2 is nothing but Z square into u dash of Z minus u naught minus u1 of Z raised to minus 1 minus 5. Z transform of u n plus 1 is nothing but Z into u dash of Z minus u naught plus 6 times Z transform of u n can be written as what here, u dash of Z equal to Z of 0 is 0. That is Z transform of 0 is 0. So 6 into Z transform of Z into un is nothing but u dash of Z by the definition. Now we'll rearrange, we'll open the bracket, Z square into u dash of Z plus into minus is minus, Z square into u naught plus into minus is minus, Z square into u1 into Z raised to minus, Z square into Z raised to minus 1 is nothing but Z raised to 1, that is I can say that Z into u1, because Z square into Z raised to minus 1 bases are same, plus 2 minus 1 will become plus 1, so that's why Z raised to 1 into u1 minus into plus is minus 5Z into u dash of Z minus plus 5Z into u naught, 5Z u naught plus 6 times u dash of Z equal to 0. Now once we got this step, so we need to collect the common things. So I can say that first term, then fourth term and the last term having u dash of Z common. So if you take u dash of Z common, we'll get Z square minus 5Z plus 6, u dash will be common among this. If you take u dash common among these three, so Z square minus 5Z plus 6. The remaining thing will be, I will take u naught common among second and last but one, that is if I take minus and u naught common, so what will be here, Z square, I have taken minus common means what here, this will become minus 5Z. Then what we have left, minus Z into u1 alone, that is we'll write as it is, Z into u1 is equal to 0. So once we got this, so we need to rearrange. So what we'll do here, so Z square minus 5Z plus 6 into u dash of z will keep on the left hand side, remaining all will shift to the right hand side. This minus u naught z square minus phi z, if you shift to the right hand side it will become u naught into z square minus phi z, and minus z u1 if you shift to the right hand side it will become plus z into u1. So once we got this step, now we'll go for the rearrangement. So we want only left hand side, we needed only what here, u dash of dash z. So we'll shift this z square minus phi z plus 6 to the right hand side. If you shift it will go on right hand side, we have two terms, so I will write like that. Just see, u dash of z is equal to, so I want to shift this z square minus phi z plus 6 to the right hand side, so it is 1 upon z square minus phi z plus 6. Then we have the right hand side terms, that is u naught z square minus phi z plus z into u1, or this step can be written as u naught into cross multiply this 1 upon z square minus phi z plus 6 to both the terms, u naught into z square minus phi z divided by z square minus phi z plus 6 plus multiply here also, so u1 into z divided by z square minus phi z plus 6. So now we know that, so if you simplify this by taking the this one simplification, z square minus phi z plus 6, if you factorize, so on factorization, so it will become u naught into z square minus phi z divided by z square minus phi z plus 6 on factorization, so it will become z minus 2 into z minus 3. So if you open the brackets, we will get again z square minus phi z plus 6. Similarly, u1 into z divided by, so this factorization is also same, z minus 2 into z minus 3. So this u0 coefficient and u1 coefficient we need to simplify. So what we'll do here, u dash of z on the left hand side. So take z transform on z inverse on both sides. So once we got this step, so we'll take z inverse on both sides now. So on taking z inverse on both sides, what here, taking inverse z transform on both sides, so we get z inverse of u dash of z equal to, so u naught is a constant, z inverse of z square minus phi z divided by z minus 2 z minus 3 plus u1 is a constant, so z inverse of z divided by z minus 2 z minus 3, and we'll do equation number 1 for this. So first we have two results here. First we need to simplify right hand side of 1 separately by taking what here, z square minus phi z divided by z minus 2 into z minus 3 as a fraction. Then we'll take a partial fraction, we'll get it answer, and similarly the second term also. So we'll take or I can say that left hand side, z inverse of u dash of z is nothing but what here, it is un is equal to u naught into pz. So I will take this, add this one as, I will take this one as z inverse of pz plus u1 into z inverse of what here, I will take this one as qz, just for our simplification, where pz is nothing but what here, z square minus phi z divided by z minus 2 into z minus 3, and qz is nothing but z divided by z minus 2 z minus 3. So we'll simplify first pz, will apply here, qz will apply here, then we can apply directly what here, z inverse to the both the pz and qz. So now take one by one. Here pz is nothing but z square minus 5z divided by z minus 2 z minus 3. So this step we need to simplify as per our previous knowledge. So among the numerator, so pz is equal to, in the numerator I will take z common. So if I take z common in the numerator, it will be z minus 5 divided by z minus 2 into z minus 3. Then this z will cross multiply to the left hand side. Already we have done the same procedure. If you cross multiply to the left hand side, so therefore pz upon z is equal to z minus 5 divided by z minus 2 z minus 3. So we'll take the LCM for the right hand side of this result. Now z minus 5 divided by z minus 2 z minus 3 is equal to a divided by z minus 2 plus b divided by z minus 3. So on taking partial fraction, on applying partial fraction, so on simplification, so above situation will become z minus 5 is equal to a into z minus 3 plus b into z minus 2. So we got this equation from the above partial fraction, and we need to find the constants values, that is a and b. So put z is equal to 3. Okay, if you put z is equal to 3 in the above situation, so therefore z is 3 means 3 minus 5 is equal to 3. If you put 3 minus 3 is 0, 0 into a is 0, plus b into z value is what here, 3 minus 2. Okay, we'll simplify. 3 minus 5 is minus 2, 3 minus 2 is 1, 1 into b is b. So therefore the value of b will be minus 2. So value of b what here, minus 2. Similarly, if you put z is equal to what here, 2, put z is equal to 2. So therefore if you put 2, so 2 minus 5 is equal to a into 2 minus 3 plus, so if you put 2 minus 2 is 0, 0 into b is 0. So therefore 2 minus 5 is nothing but minus 3. So 2 minus 3 is nothing but minus 1 minus a. So therefore the value of a will be 3. So we got the value of a, we got the value of b. So this a and b value will apply in these two results here. So this is nothing but the value of what here, means this fraction is nothing but z minus 5 divided by z minus 2 into z minus 3, but z minus 5 divided by z minus 2 into z minus 3 is nothing but pz by z. So therefore I will write the step directly. Therefore pz upon z is nothing but a divided by z minus 2. A value we got it as 3 upon z minus 2 plus b value we got minus 2 divided by z minus 3, or we can write this is a negative term, so plus into minus is minus, so we can write it is nothing but 3 divided by z minus 2 minus 2 divided by z minus 3. Cross multiply this z to the right hand side. Therefore pz is equal to 3 is a constant, z divided by z minus 2 minus 2 into z divided by z minus 3. So once we got this step, so take z inverse on both sides. Therefore z inverse of pz is equal to, so z inverse of pz is equal to 3 times z inverse of z by z minus 2 minus 2 times z inverse of z by z minus 3. So as we know the standard formula, that is Z inverse of Z divided by Z minus K will be K raised to n. The same formula will apply for the above two terms of the right hand side. So therefore left hand side Z inverse of PZ is equal to 3 into Z inverse of Z divided by Z minus 2 is nothing but 2 raised to n, because Z divided by Z minus K is K raised to n. Similar we need to write. So value of K is here 3. So therefore 2 into Z inverse of Z divided by Z minus 3 is what here? 3 raised to n. So we'll keep this as it is and I will give equation number 2. Similarly, now QZ is nothing but Z divided by Z minus 2, Z minus 3, because I have taken this from the previous step. I will show that one. So this is a QZ. QZ is nothing but Z divided by Z minus 2 into Z minus 3. So I have taken this. First simplify, then we'll apply Z inverse to the QZ and we'll get that answer will apply. So just now we got the value of Z inverse of PZ value, will apply. But before that we'll find the Z inverse of QZ. Before that, for QZ we'll simplify using partial fraction. We'll see that simplification. So here this Z will cross multiply. Therefore QZ upon Z is equal to 1 divided by Z minus 2, Z minus 3. So we'll simplify first right hand side of the above expression, that is therefore 1 divided by Z minus 2, Z minus 3 can be written as A divided by Z minus 2 plus B divided by Z minus 3. So on simplification of the above step, we'll get 1 is equal to A into Z minus 3 plus B into Z minus 2. So now we'll get the so I will take here, this is better C and D, because already A and B we have taken before. So C and D, so therefore this is C and this is D. Okay, so we'll simplify for C and D. So put Z is equal to 3 in above situation. So therefore what happened, 1 is equal to, if you put Z is equal to 3, 3 minus 3 is 0, 0 into C is 0, plus D into 3 minus 2. Therefore 1 is equal to 3 minus 2 is 1, 1 into D is D. So therefore the value of D is 1. Now we'll simplify. Put Z is equal to 2. Put Z is equal to 2. 2 minus 2 is 0 here. Therefore 1 is equal to C into 2 minus 3 plus 0. So therefore 1 is equal to, so 2 minus 3 is nothing but minus 1. That minus 1 into C is what here? Minus C. So therefore C is nothing but minus 1. So we know that we got the value of C and D. So we need to apply that C and D in this situation. But it is nothing but 1 upon Z minus 2 into Z minus 3. But 1 upon Z minus 2 into Z minus 3 is nothing but QZ upon Z. So therefore I can write the next step as QZ upon Z is equal to C divided by Z minus 2. C value is minus 1 divided by Z minus 2 plus D divided by Z minus 3. D value is 1. So 1 divided by Z minus 3. So cross multiply this Z or rearrange first. Negative term we will write next, positive term we will write first. Then we will multiply Z to the right hand side. So we will get the next step as, so we'll get the next step as multiply this Z and write positive term first. Therefore QZ is equal to Z divided by Z minus 3 minus Z divided by Z minus 2. So this step I have written first, this second, and simultaneously I have multiplied Z to the right hand side. So therefore, so now on taking Z inverse on both sides, so Z inverse of QZ is equal to z inverse of z divided by z minus 3 minus z inverse of z divided by z minus 2. So you refer the steps to simplify this problem so that you will understand once again. So z inverse of qz is equal to, so this is nothing but again the same formula. So here value of k is 3, so therefore 3 raised to n minus the value of k is in this step is 2, so therefore 2 raised to n. So we got this as expression number 3 using expression 2 and 3 in 1. So we get what here, un is equal to u naught into p z inverse of pz. So z inverse of pz answer we got it as 3 into 2 raised to n minus 2 into 3 raised to n plus second step, second one term u1 into z inverse of qz, that is 3 raised to n minus 2 raised to n. So we got these two results. So once we get these two results, so you can think whether it is possible to simplify further. If it is possible, you simplify, or else we need to leave it as it is. So I want to just open the bracket first here. So un is equal to, it can be written as 3 into 2 raised to n of u naught minus 2 into 3 raised to n of u naught. I have multiplied u naught, plus similarly 3 raised to n into un minus 2 raised to n into u1. So now I want to simplify this one as, so I will take first two terms, so first and the last term. So from first and last I want to take 2 raised to n common, and from the second and the third term I will take what here, 3 raised to n common. So therefore un is equal to, from the first and the last one, so I will take 2 raised to n common, so therefore I will get 3 u naught minus u1 of 2 raised to n is common, and from second and third I will take minus common, then I will take 3 raised to n common. So what I have left inside, 2 u naught minus u1 or I can say that un is equal to c1 2 raised to n minus or plus c2 3 raised to n. Okay, where c1 is nothing but 3 u naught minus u1, and c2 is nothing but minus times 2 u naught minus u1. So which are where c1 and c2 are arbitrary constants, and the above un is what here, required difference equation, is the required difference equation where c1 and c2 are what here, arbitrary constant. So in this way the solution is simplified for this application of Z transform.